For this lesson, we're going to take a look at some properties of quadratic functions in standard form. But first, we are going to talk and review a tiny little bit about a form that we have previously looked at, which is this one here. We were doing some graphing with that recently. That form is actually called vertex form, and it is typically written like this if you're going to do it kind of generically. So you can see we're in the same form here. There are technically 5 variables right now in this general form. We have this y equals here, so there's a y out in front. And then we have a, x, h, and k. When you are learning about lines, you learn about slope-intercept form. And in slope-intercept form, y equals mx plus b, there are 4 variables, y, m, x, and b. The x and the y stay in the equation, but you have numbers in place of the other variables. Same thing here. We have 5 variables there. When we look at an equation, 2 of them are going to stay, the x and the y. The y will usually be in the form of an f of x. And then the rest of the values will be numbers. So a in this problem is a negative 1/2. This one here for h is a little tricky. And that's because the formula here, vertex form, that has a subtraction here in front of the x, which means we do need to change the sign here when we are determining what h is equal to. So here we have in parentheses an x plus h. Here we have in parentheses an x plus 5. But because the formula has x minus h and there's a subtraction in the formula, h is actually equal to a negative 5 for this problem. And k, because it's a plus k, it is just this value on the end. So if we were going to write down what a and h and k are equal to, a in this problem, that is what is being multiplied in front. That's a negative 1/2. H in this problem is whatever is added or subtracted in the parentheses, but you do have to change the sign. So it's an x plus 5 here. So h in this problem is actually a negative 5. And then k is whatever's added or subtracted on the end, and if it's a plus, it's going to be positive, and k will be negative if it is subtraction. So k in this problem is a negative 8. So identifying those 3 values, we have a is negative 1/2, h is negative 5, and k is a negative 8. Here's one of the things that vertex form does for you. It tells you where the vertex is just by looking at the equation. When we were looking at this earlier, we started these problems with some graphing. We would start with the parent function vertex, which is at 0, 0, and then we would look at transformations, and this would slide our graph left 5 and then down 8. But if you go left 5 and down 8, your vertex would be the point negative 5, negative 8. So your vertex is always going to be h comma k when you're using vertex form. You can think of it using horizontal and vertical shifts, or you could use h and k. Both of those would be fine. So for this particular problem, your vertex is at h comma k, which is negative 5 comma negative 8. The directions say to identify the axis of symmetry. In order to identify the axis of symmetry, you do need to know where the vertex is located. Here's the idea behind the axis of symmetry. When you go through and you do your graphing for your parabola, you're going to end up with 5 points. You have a vertex, and then you go over and up a certain distance to the left and to the right of the vertex and get 2 more points, and then you go back to the vertex and you go over and up some more, or you could just make an XY table. So you end up with a graph that is a U-shaped graph, kind of like that. The axis of symmetry. That is not really part of the graph, but it does help give the graph some shape. There is a dotted vertical line that we could put in right here that would split that graph exactly in half. I use the dotted line because it's not part of the graph. The graph is this parabola that's here. If we folded this piece of paper right on the dotted line, this right side would fold over and be exactly on top of the left side. So this red dotted line right there, that is the axis of symmetry. So if we're supposed to identify the axis of symmetry, this is where it would be. We just said the vertex is at -5, -8. So if we were graphing this, this point would be at -5, -8. And then there is a vertical line that we could draw through the point -5, -8 called the axis of symmetry. Because it is a line, we're going to need an equation of a line for our answer. But that's pretty easy because it's a vertical line. All vertical lines have the same form. All vertical lines are the form x is equal to a number. So because our axis of symmetry is vertical, and it always will be for the parabolas we're looking at, it's going to be x is equal to a number. And x always has to equal the x-coordinate. It is going through -5, -8, and the x-coordinate at that point is -5. So the answer to this problem is that our axis of symmetry is the line x is equal to a -5. So as you go through and you identify some of these, if you have an equation that is in vertex form, you can look at it and determine the vertex. And then you just do x is equal to the x-coordinate to get your equation for the axis of symmetry.